All right, welcome to the part 2 video for chapter 1. In the last part, we were talking about equations and expressions. Now we're going to be talking about inequalities and absolute value. So our first thing that we're going to look at is how do we graph inequalities? Inequalities, such as the ones that we're seeing here, are graphed on a number line. So when we're looking at the inequality, x is greater than 4, we can graph that by coloring in all of the numbers that are greater or bigger than 4. So how do I know when to color in 4 or when not to color in 4? Well, is 4 greater than 4? Is 4 greater than 4? No, 4 is equal to 4, so it's not greater than 4. That's how we know to have a hollow circle or an open circle at 4. So an open circle is when there's not an equals to, right? If 4 is equal to 4, then we would color it in. So that's our second example here. X is greater than or equal to 4. So if x is bigger than 4, but also if x is equal to 4, then we're coloring it in. And so we're coloring all of the numbers that are bigger than 4, all of these numbers that are bigger than 4, but also equal to 4. So that's why 4 is colored in that second example. In our third example, we are looking for all of the numbers that are less than or smaller than 4. Again, 4 is equal to 4, so we have that open circle. The open circle means that it's not equal to. It's not included in my solution. And then all of the numbers that are smaller. So smaller is going off to the left. The way that you can make sure that you point your arrow in the correct direction when you're graphing these is to test a point. So if I say my arrow is pointing off to the left, let me test 0. Is 0 less than 4? Yes. 0 is less than 4, and so that means I colored in the correct direction. It was supposed to be a check mark. So 0 works. If I tested 5, is 5 less than 4? No, 5 is not less than 4. So I should know not to color that direction. Our last example here, x is less than or equal to 4, or equal to, that's the key that tells me that that 4 should be colored in a solid circle because it has the equal to. And so we have a solid circle at 4. Less than means smaller than, so I'm coloring towards the smaller numbers. But again, I could double check. I could test 2, for example. Is 2 less than or equal to 4? Yes. And so I know that I'm coloring in the correct direction. So in Edpuzzle, I'd like you to tell me, how do you find when to fill in the endpoint? How do I know whether this is an open circle or a closed circle? Okay, let's look at another example here. For this one, we are looking at writing an inequality. So before we were looking at writing expressions, expressions have no comparison sign. Now we're writing an inequality, so there will be a comparison sign. How do I know where that comparison sign goes? Is the key word. So because it says is at least, that's going to tell me that this is an inequality. Is at least, is at most, is more than, is less than. So if it says is with a comparison, that's going to be an inequality. If it just says the word is, that's going to be an equation. So is like equal, is with a comparison is an inequality. So the first step to writing this inequality, I need to write this expression. You should have 2 expressions, one on either side of your comparison sign. So 5 fewer than a number, fewer is one of those that goes backwards. 5 fewer means I'm subtracting 5 from something. Subtracting it from what? From a number. We want to put a variable. It doesn't matter which variable you use. Maybe we'll use n for number. Is at least, that's going to be our comparison sign, 12. So think of an example of a number that is at least 12. Let's start with 12 itself. Is 12 at least 12? Well, let's think. If I need at least 12 grains of rice in order to make a recipe, is it sufficient if I have 12? Is 12 grains of rice at least 12? Yes. So equals, because 12 equals 12, works. Let's pick another number, maybe 7. Is 7 grains of rice at least 12? If I have 7 grains of rice, do I have enough to make my recipe? No, that doesn't work. And 7 is less than 12. So less than is not going to work for this inequality. And then we'll pick another number. So we tried a number that's smaller than 12. We tried 12. Let's try a number that's bigger than 12. What about 15? Is 15 at least 12? Well, if I have 15 grains of rice, then I have the 12 that I need in order to make my recipe. So greater than does work. So that's a good way to test what is my inequality symbol going to be. So it's going to be greater than or equal to, because those both worked. So there is our inequality. In the second example here, we want to solve and graph. First, we need to solve. And the key for solving inequalities is exactly the same as solving equations, except we need to watch for multiplying or dividing by a negative. Because if you'll recall, when you're solving an inequality, if I multiply or divide by a negative, the inequality symbol has to switch. So let's see if we can solve this inequality. Again, following order of operations, exactly the same as we would for an equation. Let's go ahead and distribute that -3. So we have -6x. -3 times -5 becomes +15, plus 1 is greater than or equal to 4. Collecting my like terms, -6x plus 16 is greater than or equal to 4. We want to solve for x, so let's bring the 16 subtracted from both sides. Make sure that when you're subtracting or adding the number to both sides, you're double checking that it makes 0. So I had a +16 and a -16, it canceled out to 0. The reason that's important is because a lot of times we'll, especially if it's a negative number and we're adding to both sides, you might forget to switch the sign and to add the opposite. And so double checking that that makes 0 is going to prevent you from making some calculation mistakes. So we got -6x is greater than or equal to 4 minus 16. Well, the -16 is bigger, so I know my answer is going to be negative. And they have opposite signs, so 16 minus 4 is 12. And then I need to divide both sides by -6. And this is what we were talking about. We have to watch out because when we're dividing by a negative number, the number that I'm dividing by is negative, that inequality sign is going to have to switch. So the -6 cancels with the -6. We get that x is not greater than anymore, but less than or equal to, and -12 divided by -6 is 2. So here's my solution. X is less than or equal to 2. +2 because it was a negative divided by a negative. And so I'm going to go to my number line and I'm going to find 2. And then I'm going to determine, do I color it in or do I leave it hollow? Well, I have an or equals to, so that means I'm going to color it in. And then we have to determine, is it going to the right or going to the left? So let's pick a number and test it. Let's test 0. 0 is a nice number to test. Is 0 less than or equal to 2? Yes, 0 is less than 2. So that tells me we are going off to the left. If the answer had been no, then I would draw my arrow the other way. I would test 5, for example, or 10. And then I draw the arrow in the direction that gives me a true statement. Okay, another way to double check your work is to take any answers that I colored over, so for example 0, and substitute that back into the original equation. What that will help with is if you forgot to switch your inequality sign, you'll be able to catch it by checking your work that way. Okay, let's take a look at another example here. We want to know if these are always, sometimes, or never true. And so the way that we're going to tell that is we're going to solve. And just like when we were solving equations, those always, sometimes, or never come into play with depending on what our inequality statement is. So let's solve this first one. We're going to distribute the -2. So we get -6x minus 2 is greater than negative 6x plus 7. If I want to collect my like terms, my negative 6's are on, my x's rather are on opposite sides of my inequality sign. So let's add 6x to both sides. That goes to 0, that goes to 0. So what we end up with is negative 2 is greater than 7. Is negative 2 greater than 7? All negative numbers are smaller than positive numbers, so this is false. So remember, for equations, we said this is no solution. The same thing goes here. This will never be true, no solution. There is no value of x that will make this statement true. Let's look at our next one. Again, following order of operations, I'll distribute that 5. So we get 10x minus 15 minus 7x is less than or equal to 3x plus 8. Collecting like terms, I have a 10x and a negative 7x. So that gives us 3x minus 15 is less than or equal to 3x plus 8. I want to solve for x. So again, notice I have an x on both sides of my inequality statement. So if I subtract 3x from both sides, those will cancel out. And we are left with negative 15 less than or equal to 8. Now, how come I didn't have to switch the inequality sign when I took away the negative 3? Well, that was subtraction. The reason we switch an inequality statement is for multiplication and division. So subtraction, I don't need to switch the sign, only for multiplication and division. So for this one, we have negative 15 is less than or equal to 8. Is that true or false? Well, a negative number is always going to be smaller than a positive number. So this is true. And that means that this will always be true. No matter what value of x you put, that statement will always be true. You can pick any value of x. And then our last one here, again, following order of operations, I'll distribute the 4 and the 8. So we get that 8x minus 12 is less than 8x plus 8. I have an x on both sides of my inequality, so let me subtract 8x from both sides. They cancel out to 0. I get negative 12 is less than 8. Is this true or false? Again, negatives are always smaller than positives, so this is true. So will this always, sometimes, or never be true? This will always be true. What are our cases where we have sometimes? Well, in our last example, we saw a case where half of our number line was colored in. That is an example of sometimes being true. When it's sometimes, you'll have a variable left in your answer, in your inequality statement. Okay, let's look at another example here. For this example, we're looking at complex inequalities. So far what we looked at, we were looking at just one inequality statement. Now we're going to look at what if I have multiple inequality statements and I want to find out if they're both true. So we have two different ways of comparing inequalities. We have and when I say and, that's more exclusive. For example, if I say that I would like a pencil that's mechanical or has an eraser, that's less specific than saying I would like a pencil that's mechanical and has an eraser. Because if I'm looking at a pencil that is mechanical and has an eraser, then I need a mechanical pencil with an eraser. This is my approximation of a mechanical pencil. Mechanical pencil with an eraser. That's the only type that will satisfy that. If I say or, I'd like a mechanical pencil or one with an eraser, then I can have a mechanical pencil that has no eraser. I can have a regular pencil with an eraser. Or I can also have a mechanical pencil with an eraser. All of those satisfy my or statement. So I have a lot more options for or than I do with and. So when you're solving inequalities and you say, I need this equality and this equality, your answer should be exclusive. Your answer is going to be smaller. So let's look at what that looks like. The first step is to solve each of the equations separately, or the inequalities separately. So we're going to subtract 1 from both sides. We get 6 is less than 2x. Divide by 2, that's not a negative, so I'm not going to switch the inequality sign. 3 is less than x. Then we go and we solve our second inequality here. I don't have anything to subtract, I'm just going to divide by 3. So we get that x is, again, that was a positive 3, so I don't switch my inequality sign, less than or equal to 6. And then when we graph this on a number line, I'm going to graph my critical values, the 3 and the 6, and I like to put them in reference to 0, 0, 3, 6. Now, I'm going to use a different color in order to graph each of the inequalities, and then I'll use red in order to graph the final answer. So I'm going to say, what does x is, or 3 is less than x look like? Well, 3 is my critical value. Am I going to color it in? No, because there's not an or equal to. And then which way am I going? Well, let's test 0. Is 3 less than 0? No. Let's test 6. Is 3 less than 6? Yes. So I'm going that direction. Okay, I'll use green for the second inequality. X is less than or equal to 6. So I have 6 as my critical value. Is it going to be colored in? Yes, because of that or equal to sign. And then I want to know, am I going to the right or the left? So let's test 3. Is 3 less than or equal to 6? Yes. So we're going towards 3. If I got a false statement there, I would test a number bigger than 6. And now that I have both of my inequalities drawn, I have to look at the word and. And means where do they overlap? So if I look at these graphs here, they overlap only in that small little part, right? This is an open circle, so that doesn't count as overlapping. If it's an open circle with an and statement, it will stay open. And then if it's a closed circle with an and statement, as long as it overlaps the other line, it will stay closed. And then we have all of this overlap in between. And so our final solution is just that little tiny section, the numbers between 3 and 6, but not including 3. So 3.1 works, 3.2 works, 5.9, 6, sure. 3 does not work. 2 does not work. There's no coloring over 2. 7 does not work. So what does it mean that it doesn't work? It means that when you substitute that number into our inequalities, at least one of them will be false. The other type of complex inequality is the or statement. So again, with the or statement, our first step is to solve the inequalities. So I'm going to subtract 7 from both sides. K is greater than or equal to, 6 minus 7 is -1. For our second inequality, subtract 8 from both sides. K is less than, 3 minus 8 is -5. This time we have an or statement. So again, I'm going to draw my number line with my critical values. That's 0, -1, and -5. And then I'll use 2 colors again. Starting with K is greater than or equal to -1. I have a solid circle at -1 because of that equals 2. And then we'll test, is -5 greater than or equal to -1? Be careful, these are negative numbers. -5 is smaller than -1. If I owe someone $5, then I have less money than if I only owe them $1. So -5 is smaller than -1. That's a false statement. How about 0? Is 0 greater than or equal to -1? Yes, 0 is bigger than -1. So that's the direction we're going. And then we have our second inequality. K is less than -5. So -5 is my critical value. It stays empty because there's no or equal to. And then we'll test, is -1 less than -5? No, we just said that -5 is smaller, right? The negative numbers to the left are smaller. All of the numbers to the left are getting smaller and smaller and smaller. So -1 is not less than -5. So that means we need another number. So let's try -6. Is -6 less than -5? Yes, -6 is less than -5. If I gave away 6 of something, I have less than if I gave away 5 of something. So that tells me this is going off to the smaller side. Now for an or statement, we get to take everything we drew. So we started at a solid dot on -1, going off to the right. We also get to include an open circle at -5, going off to the left. So the word or means I get to take everything. Everything that I drew goes down onto the final graph. And only the overlap goes onto the final graph. Okay? Let's take a look at absolute values. Absolute value can be thought of as a distance from 0 or a distance between two numbers. So for example, if we have the absolute value of 4, that means the distance from 0 to 4. So the distance from 0 to 4 is 4. If we have the absolute value of -4, that's the distance between 0 and -4, and that distance is also 4 units. So if we're looking at a number line, and we're looking at 0, here's 4, here's -4, both of those values are 4 units away from 0. And therefore they have the same absolute value. And the same thing can go for any number. What we're doing is essentially making those numbers positive. And so if we're solving equations that have absolute values, we have to think about no matter what our solution to that absolute value is, that solution should be positive. So let's take a look at this first example to solve. In this example, we have the absolute value of 2x minus 1 equals 5. So the absolute value of something equals 5. Well, what could that something be? Well, I know that the absolute value of 5 is 5. And I also know that the absolute value of -5 is 5. And therefore, we can say that 2x minus 1 could be 5, right? Because the inside of the absolute value could be 5, or the inside of the absolute value could be -5. So 2x minus 1 could also be -5. So we end up with two cases, and anytime you're solving an absolute value, you should have two cases that you're looking at. And really what you're looking at is, what if I have the positive copy and what if I have the negative copy? So once you have those two cases, we're gonna solve each one separately. So if we look at the first one on the left, add 1 to both sides, and we get 2x equals 6. And then to isolate x, now we have to divide by 2 on both sides. So then x equals 3. But that's not our only possibility, because we also have our equation on the left, or on the right. And so if I add 1 to both sides again, now I have that 2x equals, and here we have to be careful because we have a negative and a positive. So -5 plus 1, 1 more than -5 is -4. And then again, to isolate x, divide by 2. And so x equals, a negative divided by a positive will give us negative. 4 divided by 2 is 2. And so we actually have two solutions here. X could be 3, but x can also be -2. And when we have more than one solution, we put these curly brackets around. The curly brackets mean that it could be either one of those answers. It could be 3, but it could also be -2. And so when you're typing this in on Math Excel, you don't have to type the curly brackets, but you'll still put the comma between your answers to say that you're listing multiple answers. So for Math Excel, you don't have to put the curly brackets. As a matter of fact, don't put the curly brackets unless it specifically says to. But when you're writing your work out, you need to have those curly brackets around them. And those curly brackets say that it could be either one of those answers. Let's look at another example here. So here, again, we have an absolute value. But if I'm looking at this, I say 3 times something minus 1 is 8. What is that something? Well, I can't tell right away. So what we want to do is we want to isolate those absolute values. I want to know, what is that absolute value going to be equal to? So in order to isolate that, I'm going to follow my, my same equation solving skills. I'm adding 1 to both sides. So really I'm thinking of this whole thing as a variable that I'm isolating. So now we have 3 times the thing I'm isolating, which is x plus, or the absolute value of x plus 2, equals 8 plus 1 is 9. Still isolating the whole absolute value, so in order to isolate that, I need to divide by 3. So if I divide both sides by 3, now I have the absolute value of x plus 2 completely isolated, and I know that it has to be 3. So what does the inside of the absolute value have to be? Well, this inside of the absolute value has to be either 3 or negative 3. So we have that x plus 2 equals 3, or x plus 2 equals negative 3. So again, we have the absolute values, we have 2 cases. Subtract 2 from both sides of our equation, and we get that x equals 3 minus 2 is 1. Let me switch colors. I think this one is a little hard to see. So we subtracted 2 from both sides of the equation, and we get that x equals 1. Then we'll do the same thing for our equation on the right. Subtract 2 from both sides of the equation. X equals negative 3 minus 2. They're both negative, so this is going to be negative 5. So our solution here, x can equal 1. It can also equal negative 5. So we have 2 options for our answer. Now, what does that mean? That means that if I substitute 1 in for x, I'll get a true statement. If I substitute negative 5, I will also get a true statement. So let's look at what that looks like. What happens if I substitute 1 in for x? So then I would have 3 times the absolute value of 1 plus 2 minus 1. Order of operations, I'm going to simplify inside of the parentheses, which is inside of our absolute values first. 3 times the absolute value of 3 minus 1. Now, what is the absolute value of 3? The absolute value of 3 is 3. So that's 3 times 3 minus 1. And 3 times 3 is 9 minus 1, which is 8. Notice that matches my solution. If I substitute negative 5, I will end up again with 8. And that's why I have 2 solutions, because 2 different numbers work to make those sides, both expressions, equal to each other. Okay. Let's take a look at another definition. So now we're going to start combining absolute value and inequalities. Oops. Here we go. So we said that an absolute value is a distance from 0. So if I say that the absolute value of x is a, that means that x is a units away from 0. And that means that the value of x, the numbers that could go inside of those absolute values, are a or negative a, right? Because the absolute value of a is a, and the absolute value of negative a is also a. And so if we graph that, we have these 2 points. We have the point a as well as the point negative a. And so those are just dots on our number line. We're not going to put anything in between them, because if I have a different value than a, its absolute value will not equal a. However, if we change that equation into an inequality, then I say the distance is less than a. So the distance from 0 to a is, or the distance between 0 and x is less than a. All of the points up until a. Okay, so let's look at this as if we put a number in there. If I look at the absolute value of x is less than 2, I want all of the numbers less than 2 units away from 0. That's another way of interpreting this. All of the numbers less than 2 units away from 0. And so then I would say, okay, on a number line, here is negative 2, here is 2. Those are the things that are 2 units away from 0. So what is less than that? Well, 1 is closer to 0, -1 is closer to 0, and all of the points in between. And so we end up with a line connecting 2 points. Now, if there's not an or equal to sign, again, we have those hollow points because those points are not included. If we have the or equals to, so if we're looking at this case with the or equals to, then we would color in those points. So again, if there's an or equal to, then we have solid or closed circles. If there's no or equal to, then it's hollow. You can see straight through that circle. The other side is, what if I have a distance greater than A? So I'm going all of the points that are farther than A away from 0. So if I'm farther away from A, then I'm saying not all of the points that are closer, like we were just looking at with the less than, but all of the points outside. So I'm saying not between 0 and A, but everything farther than that. So again, thinking of absolute value in terms of distance. And then again, if we had an or equals to, so this case with or equals to, then these dots are colored in. So if it's or equals to, the dots are colored in. Without an or equals to, the endpoints are hollow circles, empty circles. Okay, so the trick here, how do I remember if it's closed, if it's the part in between or the part outside? And the way that, the trick that I use for less than is to think less than. And remember, and is the part that overlaps. It's the part that's shared. So that's the part in between. And for greater, it's great or. So great or is the parts that are pointing away. It's everything outside. So we have a less than or great or. So when we're solving this, again, we're going to be splitting our absolute values into 2 cases. And if I have a less than sign, those 2 cases become an and statement. If I have a greater sign, those 2 cases become an or statement. So less than is for overlap. Greater is everything. Let's look at an example. So for this example, we're looking at the absolute value of 2x minus 1 is less than 5. So the first thing I'm going to do is I say that is a less than and. So less than, and I put a little d so that I can see the word and. So this is going to be an and statement. To get my 2 parts of my and statement, the first thing I do is I just copy exactly the equation or the expression given without the absolute values. So that becomes 2x minus 1 is less than 5. Now this is important. Make sure that absolute value is isolated first. So remember when we were solving the equation, we isolated the absolute value. We didn't have anything multiplied to it and nothing added or subtracted to it, just the absolute value by itself. You have to do that again for inequalities as well. So in this case, we didn't have to isolate it, but you always want to make sure that that absolute value is all by itself. And then our first case, just get rid of the absolute value bars. The second case, and this is where it gets a little tricky, is going to be the same thing. No absolute value bars, 2x minus 1, but we had a positive 5. Our other case is negative 5. Now we changed that 5 to a negative, and that means we need to switch our inequality sign. Just like when we multiply or divide by a negative number, we have to switch that inequality sign. So why do we have to switch it? Well, remember how we had defined our absolute value, it's really the inside here. That could be 5 or negative 5. So if you don't want to switch that inequality, the other way of writing this statement, the same statement, is to do negative 2x minus 1 is less than 5. The inside is switching from positive to negative. And since the inside is switching from positive to negative, in order to get that inside to match my absolute value, to get the same thing in my absolute values, I have to divide by negative 1. And that's why we switch the absolute value sign, or the inequality. Why we flip the inequality. Okay, so once we have our and statement, now we're going to solve. And so let's start with the equation on the left. Plus 1 on both sides. We get that 2x is less than 6. Divide both sides by 2. X is less than 3. Our equation on the right, plus 1 on both sides. 2x is greater than negative 5 plus 1 is negative 4. Divide both sides by 2. X is greater than negative 2. Why didn't I flip the sign that time? Notice I'm dividing by a positive number. Even though negative 4 is negative, I didn't divide by a negative. I divided by a positive number. And then the key here is that this is an and statement. So remember, for and statements, and I'll sketch it up on the graph, I start with x is less than 3. I find 3, no equal to, so it's an open circle. And then it's less than, so I'm going to test 0. Is 0 less than 3? Yes, so it goes towards 0. 0 is part of my solution. For our second one, our critical value is negative 2. Again, it does not have an equal to, so that's an open circle. And then I'll test 0 again. Is 0 greater than negative 2? Yes, 0 is greater than negative 2, so that goes this way. And now we're asking for and. Where do they overlap? Where do they overlap? Well, they overlap all of this space in between those two circles. So our answer is from negative 2 all the way out to 3 with open circles. And that's our answer. So we go from negative 2 to 3 with open circles. Now, so for this example, notice we're still working with absolute values. Our absolute value is already isolated, and this time we have a greater. And I wrote it intentionally, I'm misspelling it so that I have that word or. So that tells me my two statements are going to be or statements. Again, my first statement is just going to be the same thing without absolute value bars. So that's 2x plus 4 greater than or equal to 6. My second statement, I start writing it without the absolute value bars, but then I have to flip the sign because the other side will be negative. So again, the same reason as before, when I flip the sign, it's because I'm really multiplying through by a negative 1. But the reason the negative 2 or the 2x doesn't become a negative 2x is because it's in those absolute value bars. So here we're going to go ahead and solve, starting with the one on the left. Subtract 4 from both sides of the equation. We get that 2x is greater than or equal to 6 minus 4 is 2. Divide both sides by 2, and we get that x is greater than or equal to 1. Our equation on the right, subtract 4 from both sides. 2x is less than or equal to a negative, and a negative makes a bigger negative, so that's negative 10. Divide by 2 on both sides, and x is less than or equal to negative 5. This one is an or, that means we take everything. So again, I'm going to graph it up at the top. X is greater than or equal to 1. That's 1. It's got an or equals to, so that means I'm putting a solid dot. Let's test 0. Is 0 greater than or equal to 1? No. So that means it goes on the other side. So let's test 3. Is 3 greater than or equal to 1? Yes. So we're going to go that way, where 3 is part of our answer. And then we'll do our next solution. X is less than or equal to negative 5. It has that or equals to, so that's a solid dot at negative 5. Let's test 0. Is 0 less than or equal to negative 5? No, 0 is bigger than negative 5. So let's test a number on the other side. So if 0 was on the right, we'll test a number that's on the left. So let's try negative 7. Is negative 7 less than or equal to negative 5? Yes, it is. So we're going towards negative 7. So our final solution, we have a solid dot at negative 5 going off to the left, and a solid dot at positive 1 going off to the right. Why didn't I ask myself for the overlap? We don't have to look for overlap when we're looking at or. Overlap is for and. So because this is an or statement, we take everything. Or is everything. Okay, that's it for this lesson. There are some practice problems here. And your homework is not on Math Excel. You don't have any Math Excel homework, but you do have some practice problems. So these are posted on Blackboard under the assignment. Make sure you're writing out your work. And then we will talk about if you have any questions, and we'll do some practice in class together on Thursday or Friday. So whenever you have class, we'll go through any questions on this lesson and we'll start the practice problems. But these are just to see if you kind of got the general idea from the lesson. Okay, if you have specific questions, always feel free to email me and I'll do my best to respond in a timely manner.